In the last class, we started chapter 7, which is on Central Limit Theorem. And we did a team activity, and then we also did go through a problem. The length of time a particular smartphone's battery lasts follows exponential distribution with mean 10 months. A sample of 64 of these smartphones is taken. What is the standard deviation? What is parameter m? So this is coming from like previous chapters when we went over exponential. And basically, like as we move to the next parts of the question, it will start involving central limit theorem, like how exponential distributions also change to normal distribution when sample size is high. So this random variable x, amount of time the smartphone battery lasts, follows exponential distribution with the mean of, I would say, 10 hours. Part of 11a. So if you go back to exponential distribution, I had given you that mean and standard deviation for exponential distribution is always equal. So if mean is 10, then standard deviation equals mean equals 10. Second part of the question is, what is the decay parameter m? It's the reciprocal. If it is 10, then m is 1 by 10. Number 12, what is the distribution of length of time one battery lasts? X follows exponential with mean equals 10. 13 is, what is the distribution for mean length of time 64 batteries last? Now things are changing in 13. It's not talking about one battery, but it is talking about mean length of time 64 batteries last. So distribution of x bars. Instead of x, I would say x bar. And x bar, which is average of 64 sample size, because of central limit theorem, will follow normal distribution with the same mean as exponential. So mean doesn't change, but standard deviation, instead of that we use standard error term, sigma divided by square root of n. If I make a picture here, small picture, so average is x bars will follow normal distribution with mean 10 and standard deviation equal to standard deviation of individual values divided by square root of n. And n is 64 in the problem, so 10 divided by 8. So this is called standard error whenever we are dealing with x bars. Let's look at 14. What is the distribution for total length of 64 batteries? Instead of average, we are looking at the total. So instead of x bar, we say total of x. So that summation sign, this summation sign is basically add everything that comes in front of it. So that follows normal distribution also. The only difference is now because you have 64 smartphones, each has average of 10, so 64 times 10. So average will be 640. 10 divided by 8 is 5 by 4, 2.5 by 2, so 1.25. So let's correct that. And this is 10 times 64, 1.25, 64. So that is 80. So instead of average, we are finding distribution of the total. The only thing that changes is we multiply both by n. Find probability that sample mean is between 7 and 11. very straightforward. So you have normal distribution. So this is distribution of x bars where average is 10. Batteries last 10 hours with the standard error like sigma of x bar 1.25. So 7 may be somewhere here, 11 may be somewhere here. So this area. We use probability NORM, and then area to the left of 11 minus area to the left of 7. So that should give us the answer. Number 16, find 80th percentile for the total length of time 64 batteries last. We draw a picture. So instead of x bar, I am putting total of x. And we found that the total follows with 640 and 80. So I'm going to write 640 here. And the standard deviation we are using is 80. Area is 80% to the left. So obviously that point will be somewhere here to the right of the mean, so that the area is more than 50%. So this is 0.8. If that is 0.8, then how much is this value? So that's what this question is asking. So for percentiles or quantiles, we use qnorm, 0.8, 640, and 80. Now, one last thing from this chapter is a situation where we apply Central Limit Theorem, CLT, to proportions. So CLT for proportions. So there are some situations where your data is binomial, but you can still make use of normal distribution. The only thing is, when you convert from binomial to normal, so you have some proportion, and then you have this p bar, average of proportions, and then your sigma of, or the standard error sigma of p bar is given by average p times 1 minus p bar divided by n. So it's only a matter of converting and getting averages and standard deviation, and then we can use normal distribution for proportions. So let's look at number 33. A question is asked of a class of 200 first-year students, and 23% know the correct answer, so that P is given, or average P. Average proportion is 0.23, so 23% is 0.23. If a sample of 50 students is taken, what is expected value of mean of sampling distribution of sample proportions? So expected value is nothing but mean. That's one. And if you continue to 34, same situation, but it is asking about what is the standard deviation. So what will be mean and standard deviation for proportions? So that's the question. So average P is given as 0.23. So that is going to be mean. So if I draw this picture for proportions, the question was what is going to be mean? Mean is going to be same, 0.23. Second question, 34th one was what will be the standard deviation? If we have distribution of P's and mean is 0.23, then what is this standard deviation? So for that, we use this formula. You can say sigma of P equals square root of P times 1 minus P over N. So P is 0.23 times 1 minus 0.23 by N. N is 50 and square root of that. So this is going to be the number for standard deviation. 0.06.